8.4 is really just going to build, as always, on 8.3. And the beautiful thing about 8.4 is that we're really not doing anything different than what we've been doing. We're simply identifying names for special products. And remember, the product is just multiplying these two polynomials together. So let's actually start by reviewing. Let's multiply together. Since this unit is all about factoring, we want to multiply so that we can then look at things a little bit backwards. So go ahead, pause the video, multiply that those two binomials in the left-hand box, and then unpause the video and see how you did. So this should give you 4x squared minus 6x plus 6x minus 9. And when we combine like terms, we just get 4x squared minus 9. And this middle term adds to be 0 because what we have here is a special relationship, and that special relationship is called the difference of squares. Because we have two perfect squares, 4x squared is a perfect square and 9 is a perfect square. And when I say perfect square, I mean that we can square root it evenly. And when I say difference, I mean that the sign in between these two things is subtraction. So if we can recognize that we have a difference of squares situation happening, that can actually make factoring go a lot more efficiently. If we notice that there's no middle term, that should help us identify a pattern, which means we're not really so much guessing and checking as we are factoring, right? Because we're working in the opposite direction, from the bottom up to the top, from the binomial up to the polynomial. Hopefully that can help us identify that relationship. So I'm going to do the box on number 1 down here. This says x squared minus 9. And if you didn't recognize that this is the difference of squares, that's okay. I'm going to make a little note of it. This is the difference of squares. And the way I can tell that is because x squared is a perfect square and 9 is a perfect square, and I'm subtracting the two of them, and there's no middle term. So it's a binomial instead of a trinomial. So what multiplies to be x squared? X times x. And what multiplies to be negative 9, but then also adds to be 0? Well, this is a perfect square. So what's the square root of 9? It's 3. And I need one of these to be positive and the other to be negative. So this would give me negative 3x plus 3x. That gives me 0. So this difference of squares is going to factor to be x plus 3, x minus 3. X plus 3, x minus 3. Which we talked about this as a special product in the last unit. Now we're saying we can factor using the fact that we know and recognize that this is a difference of squares. We can factor that more efficiently. Now, if you look at number 2 down here, this does not look like a difference of squares for a variety of reasons. First of all, it's 3 terms. It's a trinomial instead of a binomial. And second of all, there's no subtraction happening at all, which means it's not the difference of anything because we're not subtracting. Let's look at number 3. The first thing that I notice about number 3 is that it is a binomial, 2 terms, and that we are subtracting. So we are subtracting 2 terms. I'm missing that middle, so I have no bx, or I have no x term in the middle. I'm just going to call it, say, no x term. So then I'm going to ask myself, what I have are these perfect squares. Well, could I evenly square root 4x squared? Absolutely. If I took the square root of 4x squared, I would get 2x. Then I'm going to ask myself, can I evenly square root 25? Sure, that would be 5. And since this is the difference of squares, the other term would be negative 5. I can just quickly check to make sure that this is the right way to factor this. 10x and negative 10x, that gives me 0. That makes me a happy camper. So this is also an example of the difference of squares. Now, what I want you to do, and we're going to come back to talk about perfect square trinomials, but what I want you to do is look at the bottom 4 questions here, 4 through 7, and I want you to identify which, if any, of these are are the difference of squares. Identify which ones are the difference of squares. Go ahead and pause the video and work through that. And if you can identify that it's the difference of squares, go ahead and factor it. Okay, so number 4, binomial, check. Subtracting, check. Can I square root 16x squared? Sure, that would give me 4x. Can I square root 1? Sure, the square root of 1 is just 1, so 4x plus 1, 4x minus 1. Let's double check. This is 0. That makes me a happy face here. So this is going to be 4x plus 1, 4x minus 1. So yes, this is the difference of squares. Let's look at number 5. Well, right now, binomial, yes. Subtraction, yes. Perfect squares, not right now. But one thing that I do notice is that there is a GCF, and Miss Judson has harassed me all year saying that I need to check for that first. So what happens if I factor the 3 out? That would leave me with 2x squared minus 3. So this is not a difference of squares. I did factor it. I factored out the GCF, and this is in fact as factored as it can get. That's as factored as it can get, factoring out the GCF, but this is not a difference of squares, so it's not one of those special products. Use that same idea on number 6. Go ahead and pause the video. Okay, number 6. Subtraction, binomial, missing the x term in the middle. So far, so good. Right now, I can't square root 2x squared, but is there a GCF? There absolutely is. That's 2. If I factor a 2 out, what's left is x squared minus 16. So now ask yourself, looking at what's left on the inside, do I have a difference of squares? And yes, I do. X squared I can evenly square root, 16 I can evenly square root, so this is going to become 2 times x plus 4 times x minus 4. So yes, this is a difference of squares. We just had to factor out the GCF first to notice that it was a difference of squares. Okay, number 7. 2 terms, so it's a binomial. That's a good sign. Both terms are perfect squares. That's a good sign. But what's the issue here? This is not a subtraction sign. So this is not the difference of squares. It doesn't have a special relationship, and in fact, it is not factorable. So now that we've talked a little bit about difference of squares, there's one more special relationship that we have to talk about, and that is called a perfect square trinomial. And the perfect square trinomial is, let's actually start by multiplying one of them, as we talked about in the last unit. So go ahead and pause the video, come up to this box up top that says perfect square trinomials, and go ahead and do that multiplication in the box there. All right, well, this would give me 4x squared plus 6x plus 6x plus 9, 4x squared plus 12x plus 9. And this is called a perfect square trinomial, perfect square trinomial. And that happens when you multiply something by itself, right? I could multiply this, I could rewrite this as 2x plus 3 quantity squared, and that would give me this. And here's the pattern that you can notice about this. The first and last term are perfect squares. First term, how come it won't let me change my color? There we go. First term and last term are perfect squares. But unlike the difference of squares, there is a middle term. And that middle term is what you get when you double the product of what's inside. So if I multiply 2 times 3, I get 6, and I double that, I get 12x, and that is what is inside. This one is less important for you to notice. I don't think it always helps you with factoring. Difference of squares makes a big difference in factoring and helping you out there. But what I notice when I look down here at number 2 is that I have a perfect square and a perfect square. And the middle is what I get when I take the square root of each of those and multiply it together, 1x, and then I double that. So this ties back to that relationship that we talked about in Unit 7. So this is going to be x plus 1 times x plus 1, or we could rewrite that as x plus 1 quantity squared to factor this expression. So the big idea in this section is recognizing those special products, because if you can recognize that the result that we're looking at in this unit, if we're looking at the polynomial and we can think back and say, hey, this is what we get when we multiply a perfect square, or this is what we get when we multiply a difference of squares, that's going to help you be more efficient with your factoring, which is really the goal of this section, to help you find some tricks to be more efficient when you're factoring. So it's really important that you can recognize a difference of squares squares and how to factor that, and especially trickier problems like number 6 where you have to take out that greatest common factor first. So write down any questions that you have, and I look forward to supporting you on this in class. Thanks for listening.